Hello viewers, today we will discuss about the architecture of Intel 8088 microprocessor. The block diagram of Intel 8088 microprocessor is divided into two parts. First one is execution unit, second one is bus interface unit. The execution unit, it takes care of the processing including ALU. Second one is bus interface unit. It controls the passing of information between microprocessor and external interface device. Today we will discuss about bus interface unit. Bus control logic. Bus control logic is made up of a set of logic gates that controls the access of external bus of 8088. This includes all external memory devices, input and output units that communicate with the processor through the bus. Instruction queue. It handles or arranges instructions in a sequential manner so that code was executed correctly and faster. Microprocessor uses three steps to perform any activity. First one fetch, second one decode, third one execute. The bus control logic performs the fetch function. It means it copies instructions from memory according to your input. EU control system performs the decode function. Means it decodes the instructions and figures out what operations it should perform to complete the activity. The ALU performs execute function. If the bus control logic is done fetching the current instruction, it may have to guess what the next instruction is to be fetched. Then the EU control system won't have to wait for the next instruction to be fetched once it is completed decoding of the current instruction. And once EU control system has finished decoding of current instruction, it will decode the next instruction guessed and fetched by the bus control logic. Then the ALU won't have to wait for fetch and decode of next instruction. This is called pipelining, and it is an important method for speeding up the operation of a processor. In this example, we can easily understand how much time is saved with pipelining. F represents fetch cycle, D represents decode cycle, E represents execute cycle. Processor operation without pipelining. It takes 15 cycles to execute 5 instructions. Now let's see how fast those 5 instructions have executed with processor operation with pipelining. 15 cycles reduce it to 7 cycles to execute 5 instructions. It can make a processor faster. Number of cycles is required for a non-pipelined processor is equal to 3 into number of instructions. Number of cycles for a pipelined microprocessor is equal to 2 plus number of instructions. If 50 instructions, non-pipelined processor needs 150 cycles. The pipelined processor can execute these 50 instructions in 52 cycles only. The number of cycles of a pipelined architecture is almost 1/3 of the non-pipelined architecture. It means the processor is very fast when pipelined architecture is used. Instruction pointer. It can be found below the group of registers. It's just like pointer and index registers in execution unit. The only difference is the instruction points the next instruction to execute from the memory. Segment registers. In the center of the BIU, there is a set of registers labeled as CS, DS, SS, ES. These 4 registers are segment registers. These registers are used in conjunction with pointer and index registers to store and retrieve items from memory space. CS means code segment register. It points the area of the memory where the code is stored. DS means data segment register. It points the memory where the data is stored. SS means stack segment register. It points the area of the memory where the processor temporarily stores a value. DS means extra segment register. It points wherever the user wants it to point. These all registers are 16-bit long. Segment and pointer registers are set up to operate in pairs for a specific purpose. Code segment and instruction pointer points to the address of the next instruction in the memory to execute. Stack segment stack pointer points a temporary storage place for data. Data segment destination index points where data is to be stored. Data segment source index points address in memory where data is to be retrieved. If you look carefully, the 8088 address registers are 16 bits wide, but the address space of 8088 is 20 bits. Are 4 of address lines are not used? Of course not. The combination of two 16-bit registers makes a 20-bit address line. Left 16 bits number from segment registers, right 16-bit number from pointer and index registers is added in address summing block to make a 20-bit address bus. The address summing block located directly above the segment registers in the bus interface unit. Next time, if your Windows system throws an error, just look to see from what address the error occurred. It shows something like this. This number is actually a combination of two registers. The left number from the segment registers and the right number from pointer and index registers. Note that 4-digit hexadecimal number results a 16-bit binary number. The combination of two 16-bit registers that creates a 20-bit address line. Let's observe how the summing activity is done in address summing block. The value in the segment register shifted to 4 places left to add 4 zeros in the right side of the number. The hexadecimal number 3241 becomes 32410. Then this value is added to the pointer or index register's value. The answer is 20-bit number. This computation takes place in address summing block. Therefore, the process of trying to access a single location in 8088's processor memory space takes 3 things: a 16-bit segment address, a 16-bit offset address from pointer or index registers, a 20-bit physical address which is output from address summing block. There are two purposes for the summation of segment and pointer and index registers to access a single location in memory address. First, it allows the processor to access more addresses like 20 lines than it has bits in address registers, 16 bits. The most significant reason is that it allows you to load multiple programs at one time. It is called relocatable code. This means you can load Microsoft Word and PowerPoint at once. That's all for today. Follow me on my next video, pin configuration of Intel 8088 microprocessor. Thanks for watching. Please subscribe my channel and share my videos.